Hi, I want to take a look at an example of delivering power to a string under tension through some form of oscillating source. So we have an oscillating source that's hooked up to a string that happens to be under 40 newtons of tension. And the string has a linear mass density of 1.2 grams per meter, which would be 1.2 times 10 to the negative 3 kilograms per meter. And we don't know the frequency that the oscillator is oscillating at, but we do know it's delivering 400 watts of power at an amplitude of 0.0250 meters for vibration in the string. Now, for power being delivered to a string on average, we have a formula to calculate it where the average power is 1/2 times the linear mass density mu times our angular frequency omega squared times our amplitude squared times the speed of the wave on the string. And the speed of a wave on a string is the square root of the force of tension in the string divided by the linear mass density. So if I want to solve for my frequency, I can start by solving for my angular frequency omega. And omega squared is going to be 2 times the power divided by the linear mass density divided by the speed, which is the square root of the tension over the linear mass density. So I could combine those two together, divided by the amplitude squared. So if I take the square root of that, I'd have the square root of 2 times the power delivered divided by the linear mass density times the force to the 1/4 power, and the square root of the amplitude squared gives me my amplitude A. And since omega is 2 pi times my frequency would be 1/2 pi times that quantity for omega. So if I plug in my value for power, 400 watts, my linear mass density 1.2 times 10 to the negative 3 kilograms per meter times 40 newtons, multiply them, raise it to the 1/4 power, which is the square root of the square root, and then also in that denominator end up dividing by 0.0250 meters. I end up with a frequency F of 385 hertz. Thanks for watching.